Hi everyone, welcome to the tutorial of the TSGlib, so the time series generator library. In this demo, we will quickly go over the GitHub repo, get an overview of the general parts and features of the library, and then also go through a brief tutorial to show how to apply it. So maybe first things first, TSG is a lightweight Python library for generating synthetic time series data. And the idea is to have a modular and composable approach to data generators. So what that means is that we have core generators that could be something like a linear trend, periodic trend, or anything else, basically, that's somewhat of a time series data. And then we have wrappers. Those are basically add-ons that allow us to modify the underlying generator. So that could be adding Gaussian noise or Poisson noise, or for example, clipping the range in which the time series can be expressed. And as a first component so far, we have the what we call meta generators. The idea behind the meta generator is that it uses multiple generators to combine them in, for example, a regime switching generator where we have, say, for example, a linear upward trend, a periodic trend, and then based on a rule or deterministic or stochastic rule, those generators basically change and then allow us to model more complex time series. And we also designed it in a way that it's easily extensible. So you have a base class from which you can also implement your own generators or wrappers. The TSGlib can be installed either through the GitHub repo or from PyPy directly, so that would be just pip install TSGlib. If you want to use it, it's relatively straightforward. So you just import the respective generators. So in this simple example, we import a linear trend generator and a Gaussian noise modifier, and we can simply instantiate it with the start value, a given slope, and then also the Gaussian noise. In this case, we have a mu0 and sigma 1, and then basically wrap, as the name wrapper suggests, the linear generator and the noise wrapper. And I can simply use the generate value function to generate a time series from that. And now having the basics out of the way, we can have a look at the forecasting example in which we learn how to generate time series data and evaluate forecasting models using different generators and modifiers. So what we see in this notebook, we need a couple installations. Nothing special here, just TSGlib, Torch, NumPy, Matplotlib, and scikit-learn. And then we build 3 different generators. The first one is a linear trend generator with Gaussian noise, similar to the example we've seen before. Then an Ornstein-Uhlenbeck process, which is a mean reverting stochastic process. And then we create a Markov kind of switching process that switches between the 2 regimes according to a Markov chain. And we set the series length of 1000, instantiate the 3 generators, instantiate their generate the data, which we then also see in this plot here. So we see we have different stochastic processes. And in this simple example, we then use an LSTM with a rolling window approach to forecast the next value of our time series. And if we go through all of that process, so it's just a standard training process, we see that the LSTM performs worst on the linear trend with noise, somewhat better on the LSTM on the Ornstein-Uhlenbeck process, and best on the Markov switch series. Of course, this is not a perfect model training in the sense to optimize for forecasting. It's just a quick demo to show how you can use the generators in a forecasting task. And the key takeaways that I want to highlight are that the TSGlib allows you to create time series of known structures and properties. You can easily combine generators and wrappers to simulate realistic or challenging time series behaviors. And the synthetic data then helps you explore model behavior and debug algorithms and bench forecasting models on a known ground truth, which you wouldn't have if you would use real world data, where the data generating process might be unknown, for example, in domains like finance or health. And that is pretty much it. So thank you for your attention for this quick demo, and I hope you will find this useful.